Hi, class. When you're looking at different kinds of statistical tests that can be performed, it's important that you understand the basic difference between two groups of these tests, parametric and nonparametric. The word parametric comes from parameter, or characteristics of a population. All statistical test decisions start with a researcher asking, what do I know about my data? What you know about your data informs which test you will use, because you will want to use the least weak, also known as the most powerful, test possible. You want to get the most detailed results that you can. One of our basic choices will be whether to use a parametric or a non-parametric test. As you can see in the book, there are at least two options of statistical calculations you can perform for each kind of study. Which one you choose depends on what you know or believe about the characteristics of your data. In general, parametric tests are more powerful than non-parametric tests. It's like measuring heights of people. Parametric tests are like measuring in inches, and non-parametric tests are like measuring people in feet. It's still correct, but it's much coarser and lacking in detail. Parametric tests are finer in detail and allow you to see more subtle distinctions. But they also have more strings attached in terms of assumptions they make about the population from which the sample has been drawn. With their tendency to be less sensitive, non-parametric tests may fail to detect differences that actually exist between the groups you are comparing. Individual parametric tests have their own associated assumptions that you need to be aware of. In general, though, parametric tests are used when you believe your data is normally distributed, meaning it follows the bell curve, and you think the mean will be an informative characteristic. The dependent variable can be measured at the interval or ratio level, and the variance is similar. This means both distributions are similar in height and width, rather than one being short and wide, while the other is tall and narrow. Another assumption is that the data has been collected using a random sample from the population. Also, the observations must be independent of each other. This means that each observation must not be influenced by any other observation. An example of a study that would violate this assumption would be one that looked at the TV habits of several children in the same family. The behavior of one child is likely to influence all the children in the family, so the observations are not independent. Non-parametric tests are the ones you use when you don't think the mean would be informative for your research problem. Instead, you would rank your data using the median as a more appropriate view, since extreme values would throw off the mean. It would be like looking at the incomes of a group of regular people with Bill Gates also in the room. Ranking the incomes would be a better representation than using the mean. The data can be measured in nominal or ordinal scales. Now, non-parametric tests can be used when the sample sizes are small, as well as when you don't believe the data is close to following a normal distribution. Small sample sizes can make it difficult to know if you have normal distribution. Making a stem and leaf plot, as the book shows you how to do, will tell you if you're probably wrong about normal distribution, although they can't always tell you if you're right about it. Finally, non-parametric tests do still assume that the samples were random and the observations were independent. Now, while we might always want to use the parametric test, it's important to remember that research in the social sciences does not always lend itself to data that can meet the required assumptions. Some researchers will decide to use the parametric measure anyway. They will argue that these tests can tolerate minor violations of the assumptions, especially if the sample size is large enough, usually over 30. This kind of decision must be justified in the article, including support from statisticians or previous researchers in this area. While it exceeds the scope of this particular conversation, you may also be able to manipulate your data so the assumptions are met. This is controversial, so even more justification must be found and included in your research reporting. The path requiring the least amount of justification would be to use the non-parametric technique. As you work through the weeks in this course, you will have the opportunity to explore both parametric and non-parametric tests that can be used for the different kinds of research studies you might encounter. Keeping this fundamental difference in mind as you review journal articles will help you decide if various researchers have done an acceptable job with their work and if their findings are appropriate and meaningful.